Hello friends, welcome to our channel e power 5. In this video, we'll see all the basics of mathematics. So, don't skip this video. In this class, we are going to see the importance of 0. We call 0 is hero because 0 has different operations in different scenarios. So, we will be capturing all the scenarios in this class. So, what are all those different types of zero handling mechanism we have? So these are all the total list of items we have for today. 0 has no sign. We call it neutral. 0 has no influence in addition and subtraction. 0 has more effect in multiplication. 0 behaves in two different ways in division. Anything to the power 0 is 1. Logarithm 0 is equal to 1. So log value of 0 is equal to 1. 0 factorial is 1. In combination operator, what will be the value of 0 at a particular position? Silent factor in currency notations. In decimal number system during addition and subtraction, how we need to add zeros, and zero appearances in division. So these are all the set of topics we are going to watch as a part of this class. Okay, come, let's go in detail in all topics. Zero has no signs. It's neutral. Zero is denoted with either positive sign or negative sign. It means if you put a plus to 0, it doesn't matter. Also, if you put minus to 0, it doesn't matter because 0 is sign free. Okay, 0 doesn't have any sign. If you put plus 0 or minus 0, you don't have any issue in that. Okay, so it's like sign free, we can call it. Okay, got it right? Good. Let's move on to the next one. 0 has no influence in addition and subtraction. Let's see this topic in detail with following examples. 5 plus 0. So 5 addition to 0 is equal to 5. Yes, it doesn't matter if you have a 0, okay, with plus 0 or minus 0. It is not going to appear in the sum. Okay, we'll get the answer right away. Whatever the contents like variable or numbers you have, it will fall as the answer. Similarly, 5 minus 0, as I said, 0 is not having any positive sign or negative sign. So it is not having any power in addition and subtraction. That is the main agenda of this particular example. Okay, that's why I have said like 0 has no influence in addition and subtraction. So during subtraction, if you have 0 like this, you can directly say the answer is 5. Another example, 0 plus 5. What if 0 comes at the beginning? Okay, since you are adding these two numbers and 0 is powerless during addition, you will get the answer as exactly, it's 5. Another example, 0 minus 5. As I said, you don't have power for 0 during addition and subtraction, right? So 0 minus 5, what will be the answer? Exactly, it is minus 5. We have to tell the answer along with the sign. If it is plus, sometimes we will not mention that plus sign, but during minus we have to mention the symbol. If you want to know the importance of this plus and minus, kindly see my video which I have taken on basics of mathematics, the class 1, where we have seen how to handle sign. Let's move on to the next example. X plus 0. We have seen adding numbers. So this example says that if you are adding a number and a variable and that number is 0, as I said, during addition or subtraction, 0 will disappear. Okay, it's, we can hide 0. Okay, so the answer is nothing but directly X. Okay, similarly minus y and minus 0, we can hide the 0. If you hide it and see, okay, you will see only minus y. So that's what the answer is. will increase more number of terms during addition. It is x plus 0 plus 6. As I said, 0 is not having any power during addition, so x plus 6 will be the answer. Got it right? Similarly, minus y minus 6 minus 0. Again, 0 is involved during subtraction. So we can hide this 0. There is no power during this, okay? So the answer will be minus y and minus 6. Hope this is clear. Hope you all have taken notes on this. Okay, let's move on to the next one. 0 has more effect in multiplication. Minus 5 into 0 is equal to, it's 0. So far we have seen the previous example. I was mentioning that 0 has no effect in addition and subtraction. But during multiplication, 0 is the highest number which has more power. Okay, even if you put n number of items before a multiplication 0, you will get the answer as 0. For example, we'll see all these type of example in this particular. So minus 0 cross 5, so 0 into 5, 0. Even though if you have minus to 0, answer will be 0. Next, 0 bracket x plus y. Okay, so bracket is nothing but again a multiplication operator. Okay, so even though if you have a hell lot of terms, numbers inside a bracket, but you have a 0 at the end or the beginning, you will be ending in 0. Okay, another example, 5 bracket 0 minus 3. So you have a sum inside the bracket, right? Try to solve that. 0 minus 0. Now 0 and 3 are combined with an operation called subtraction. So if you minus 3 from 0, okay, as I said, during subtraction 0 has no effect. You can simply write as 5 minus 3, which is equal to minus 15. Okay, so yes, that's correct. Like minus 15, we have to mention this minus. Okay, if you want to know why we are having this minus here, check out on my previous videos on how to handle sign during multiplication and divisions. Okay, next example, if you have a lot of terms with the different operations, for example plus, minus, divide, if you have all the operations, but at the end if you are enclosing this inside a bracket, and if you are going to add even a small number of 0, okay, you will be ending in an answer called, obviously it's 0. Okay, so this is how 0 is playing different uh, actions in different scenarios. So the ultimate power of 0 lies in multiplication. Okay, hope you have got it. We'll move on to the next one. 0 behaves in two different ways during division. How it happens? Okay, let's see it. 0 divided by 5 is equal to, if 0 comes in the numerator, we call in division we call like numerator and denominator. Okay, so 0 right now is lying in the numerator and 5 lies in the denominator. So 0 by 5. Okay, 0 by 5, which is nothing but 0. If 0 comes in the numerator, it has more power. Again, what if 0 comes at the denominator? Okay, even though you have any number of terms, okay, but you have 0 at the division, means at the denominator, your answer will be undefined. We call it like infinity, or undefined is the answer. So in during max, we should not see 0 at the denominator, which was in some special sums we need to have 0 to bring the answer as infinity, but as a basic of max, you should not have 0 during division at the denominator. Hope you have got it. Okay, then we move to the next. Anything to the power 0 is 1. Let's see with an example. For example, 5 power 0 is equal to 1. We have here 0 at the power of 5. Okay, so any term, like even it is a constant number or it's a variable, you will be ending with an answer 1. Okay, see, a power 0 is also 1. So this is what we are calling this particular type as anything power 0 is 1. Okay, for example, if you are seeing this kind of a sum like x plus 6 minus 3, but you have a power 0 for x, so what will be the next step? As I said, anything power 0 is 1. So we can replace this x power 0 by 1 and we can write down the other terms as it is. Okay. Now you perform your operation because it is the basic sum, right? 1 plus 6 is 7. 7 minus 3 will be 4. Got it, right? So this is how 0 behaves in the power position. Okay. Let's move on to the next one. Logarithm. So we have a another operation called logarithm during in max. So the value of log 0 is equal to 1. Kindly take a note of this. Log 0 value is 1. Okay, fine. Next, in exponential, how 0 behaves. E to the power 0 is equals 1. Yeah, you have seen this sound previously, right? At the beginning of the video, you have seen that e to the power 5. Yes, it's our channel name. Here, an example and another value for e power 0. Okay, so e power 0 is nothing but 1. Okay, good. Let's move on to the next one. Factorial. Factorial represents that 0 factorial, we have the value as 1. Factorial means, as you know, like if it is a 5 factorial, it is nothing but 5 into 4 into 3 into 2 into 1. It means we have to decrease the number till 1. If you have 6 factorial, you have to decrease the number till 1. Okay, so this is one special formula for 0 factorial, where you can ask like, okay, if I want to decrease the number, because you are ending in 0, you have no numbers less than 0. Here minus is not allowed because this is like real-time scenarios where factorial comes. We call it like permutation and combination or probabilities. For example, um, if you are going to count the apples, right, you will be ending whether in 0 or in the positive numbers only. You will not say like I have minus 2 apple with me. Is it reasonable? No, right? There is no meaning in telling I have minus 2 apples or minus 3 oranges. Okay, so that's why in factorial we will be going till 1. Okay, to the digit called 1. If you are having like 3 factorial, it is nothing but 3 into 2 into 1. We have to decrease from the starting number till 1. But if you have 0 factorial, its value is 1. We have to write 0 factorial is equal to 1. So this is how it behaves in factorial. Hope you got it. Let's move on to the next one. Combination operator. Combination operator is also a part of like a probability statistics. Okay, it's nothing but NC0. You will be seeing in your curriculum, if you see NC0, then its value is 1. It means the 0 position is there, right? The right side of C is nothing but a combination operator. If you have 0 at right side of C in the bottom, then the value is 1. So NC0 is 1. Okay, now let's move on to the next one. Silent factor in currency notation. This is one of the our day-to-day experience with the numbers. Okay, if you are going to a grocery shop and if you are buying the products and if you get a bill, okay, the counter person will say like the total cost of the bill is like, say like you have purchased a chocolate and it is costing around $5. Okay, it doesn't mean it's a dollar and 5. You have dot 0 and 0 in order to indicate the cents. Okay, or in Indian rupees we'll call it like paise, right? So there is a number available next to the currency. We have to, because if you write in a paper, okay, I buy apples for $100. You can say like $100, but you can't just write like that, because you are having a a couple of zeros next to the currency in order to indicate any minute grams or any units to the cost. Okay, so this is usually people will not mention this type of zeros, but you have to keep in mind that there are zeros available next to the currency. Okay, at least we have to put a dot and two zeros. Okay, hope you have got this point. Fine, let's move on to the next one. In decimal number system, okay, during addition and subtraction, how we are going to play with zeros? Come, let's see it with an example. Okay, here I have a set of numbers, say like 5.3, 17.62, 0.85, 2.0034, 123.456. So how we will write during addition? Say for example we are going to perform an operation called addition. Okay, you have to write this number in order, right? So how we need to write? So this is the beauty of a decimal number system, that all the decimal points have to lie in a straight line. See how we are writing here, 5.3, below that we are starting the another point, right? So it doesn't mean like underneath 5 I'm writing 1, I'm writing 7 and 1 is staying left to the 5 position, right? So this is how we need to write. We have to match the decimal point. So 0.85, how we will write? Just match the point. Okay, so just keep the point in the straight line and write the number as it is. Okay, see how it is written. Okay, fine, right? We have written all these 5 numbers one below the other, and this is how we have to write the decimal number during addition or subtraction, one below the other. It means that all the decimal points should lie in a straight line. Very important thing. Okay, now moving to the next point is like, here you see that the numbers are in zigzag positions, right? The numbers are not even. It means some numbers have four digits next to the decimal point, and some numbers have 3 digits on the left side of the decimal point, right? So we have to have a commonality between all these 5 set of numbers. Okay, what we need to do? Yeah, here comes the zero. We can add zeros on the empty positions. See, we have added we have added 0 below 4. See, we have two spaces left for 85, right? We can add one more 0 to 17.621, right? See, just watch the 0 how it is coming and filling it up. On the right side the zeros are getting filled up. Now you can see, right, all the numbers are having 4 digit next to the decimal point. Similarly, on the left side, watch out for the zeros, how it is traveling and how we are entering the zeros. Okay, now we can see, right, now I have filled all the zeros in the position. Now the sum seems to be complete, right? Now we can start our addition performance. So if you add it, you will get a value of 149.2304. Got it, right? So this is how we have to use zero during addition and subtraction. Got it? Fine. Then, okay, let's see zero appearances in division. So how zero involves during division is what we are going to see now. Let's take an example. Here I have an example like 212 is getting divided by 2. Hope you all people know how to do division, right? So we are going to do the same step, but the main view of this particular example is like how zero is going to appear. Okay, so this is nothing but two tables. So how much time 2 will come? It's 1 times. So we'll put 1 at the top and we'll put 2 below the number, and we do subtraction, right? So 2 minus 2 will be 0, and the next step will be we have to bring down the next digit. Okay, we have to bring down the next digit. So 1 will be carried down. Now if you see whether 1 will be appearing in two tables, no, right? Because this is a smaller number when compared to this divisor. So when you encounter a smaller digit in between the division, we cannot able to process the sum forward, right? So what we need to do, we have to bring down this next digit. Okay, here it is 2. We have to drop this 2 to this position, but we need to get a permission. We can't just like that go ahead and drop this 2 down. What we need to do is we have to add a 0. Okay, you have to add 0 to the quotient, and then only you get the permission to drop down this 2. See, now the 2 has dropped down. So only when you put a 0, you have the permission to drop another number. Okay, now this is 12. So now the number becomes higher than the divisor. So 12 is greater than 2. So in two tables, how much time to 12 will come? Yes, it's 6 times. So if you put 12 below that and if you subtract, you will get a remainder as 0. Okay. Okay, fine. So let's see another example. Okay. Now I have a number, an odd number ending at an odd digit like 1. So it is 231. We are going to divide that number by 2. Okay. Similarly, 1 times we are going to take the first digit 2, and it is 1 times 2. So it will get subtracted. And the next step will be we have to drop the next number. So 3 will be dropped down now. Since this number is higher than the divisor, obviously you will be having multiples of 2 inside 3, right? So how much time 3 will come in two tables? Yes, 3 will not come in two tables, but you can reduce one digit, right? So it is 2. So 1 times you have 2. So we are just doing that, and if we subtract, it will get 1 as the answer, and we have to drop the next number. So, since we have 3 digit, we have to drop that next one here. Now it is 11. Similarly, in two tables, 11 will not appear. If you step one step backward, it will be 10. So you have 10 in two tables, which is 5 times 10. Okay. If you subtract 11 and 10, you will get answer as 1. Since you have to get the answer as 0 as a reminder, but you are landing in 1. So we have to complete the sum till 0, right? So what we are going to do is we are going to add a decimal point in the quotient. See, we are adding a decimal point in the quotient. If you add a decimal point, you get a permission to add 0 to the digit, okay, on the right side of the digit. So now this one becomes 10. Got it, right? If you have a dot like the decimal point, you can add 0. Okay. Now 10. So how much time 10 will come? It's 5 times 10 will come, and 10 minus 10 will be 0. Got it, right? So in these two example, what we have seen is how 0 appears in quotient and how 0 is appearing inside the sum. Okay. So you get a decimal point, you will get a permission to add zeros, and if you have a smaller digit in between, in order to make that as a bigger digit, you have to drop down the next number. So if you are dropping down another number at the same time, you have to get the permission by adding this 0. Okay, this is how 0 appears in division. We have one more example, like this is nothing but you can call like a shortcut in max. Okay, if you have the numbers getting divided by tens, hundreds, thousands, or uh, powers of tens, okay, how we need to do the division? There is a short way. Okay, let's take an example. If 123 is getting divided by 10, how we can do the division is, if you have another number, like if any other number in division like other than 10, we can't able to perform this shortcut. This shortcut is applicable only to a specific sums that is having 10, 100, 1000 and multiples of like powers of 10 in the denominator. Okay, so 123 by 10 will be 12.3. How we did in a short way is that we have to count how many zeros are available in the denominator. So in denominator, how many zeros are there? Yes, it is only 10. Okay, so we have to place the decimal point starting from right to left, right? We usually perform mathematics from right to left. Uh, so you have to place the decimal point one digit after. Okay, so you have to place the decimal point after 3, sorry, before 3 you can call, right? Either way, okay, just understand like where we are placing, by what we are placing. Okay, since we have 10, we are moving one digit from right to left to place the decimal point. Let's take another example. If 123 is getting divided by 100, so how many steps we have to move? Two zeros are there, so we have to move two digits. So 3 and 2, you have to place the decimal point in between 1 and 2. So this is the answer. Got it, right? So if you have two zeros, you will be moving two digits from right to left. Similarly, if you have three zeros, you have to move three digits. So the point will be before 1. Correct, right? We should not end this answer just like that. If you don't have any number on left side of a decimal point, then there comes the 0. So we have to end the sum. We have to complete the sum by adding this 0.123. Okay, we can say it is 0.123, but while writing you should not mention simply like 0.123, just add 0 to left of the decimal point. Got it, right? This is a mandatory rules, okay, while writing. If you don't have any digit, just put a 0 before decimal point. If you have four zeros at the denominator but you have three digits at the numerator, how we need to do the performance in mathematics? Just the same method. We have to count the digits. How many digits? Four digits, but you have only three digits. If you are lagging with any number, you need to make this as a four digit number. Just add 0, okay, to the fourth position. Okay, 1, 2, 3 and fourth position, and then put a point. This is a decimal point. So as I said, we should not leave this point alone in the front, so we have to enter the 0. Okay, so now the sum is complete, right? So now you have got the shortcut of how to divide a number in the powers of 10. Okay, great, I hope you have got it. Okay students, hope you got valuable inputs. Okay, do share this with your friends. Take a note and pen, just teach them. Okay, also you can make one more point, that you can simply share this video. Do subscribe our channel and don't forget to press the bell icon. Yeah, okay students, happy learning and thanks for watching.